says. Very good. Hello, everybody. All right, we're back at it again. Going to continue working on our hand logic, and yeah, just seeing if we can get it a bit further than it was. Not completely sure yet what we're going to be looking at exactly. There's still a whole bunch of things that I am not happy about. Um, However, let's take it all one step at a time. I think the most immediate thing right now is to complete the work in getting everything to work with PID controllers. So in the last couple of streams, we obviously implemented an Angular PID controller to control the hand logic. So let's see, where were we? Over here. So I did some cleanup off camera, but basically that's what we ended up with. It was a little bit more because the whole PID controller itself obviously is in there, but this is basically what we ended up with as logic as far as the main hand is concerned. So basically converting our current orientation. This actually, I think I need to rename this because it's not really the target local. This is really our delta bases. And this really is there for our delta quad because it's the difference between where we are and where we need to be. And then obviously we can rename that to delta axes and delta angle, which means that we need to update U and we need to update U. We need to update U. There we go. I think that naming makes more sense because, yeah, like I said, we're calculating a difference here between our current orientation and our target orientation, which gives us the delta of our orientation. And we're converting that to quaternion because we can't get the axis angle directly from our bases. There probably is some math to do that, but we're just using off-the-shelf stuff here. So we're converting that to a quaternion, and then that quaternion we can express as a delta axis and delta angle. Now I did remove all the debug stuff that I had in here that I built last stream just to debug it all. I don't think that really belongs in the end product. Although I do have to say I did really enjoy seeing the axes on the hand, so that you could actually see that we have a correct rotation there. Maybe at some point I will reintroduce something for that, but yeah, not right now. We've pretty much proven that this is the right calculation, that indeed gives us the correct axes and the correct angle. And then it's just a matter of using that. Now, at this point in time, we send our delta to our calculation. We then send our delta axis multiplied by the delta angle. So we're basically encoding the angle into the axis because the axis is normalized anyway. So we can always unnormalize it, renormalize it. And now we can extract the angle from the axis by taking the length of the axis. Excuse me, I got something stuck in my throat. And the last thing that we're sending through is our velocity. Now, the interesting thing is the angular velocity, even though it's badly described in the in our help tooltip here, is actually also a axis angle notation. So it's basically doing the same thing as this, but now with our velocity as it is being maintained by our physics engine. So those two are pretty good inputs for our PID controller. Then the PID controller itself, I've cleaned up as well. I've purely left it as a PD controller for Angular and purely left in the Angular calculation. And right now, all that we're doing is calculating our proportional gain and our derivative gain. Now, one of the things that I have been thinking about doing because of stuff that I've been reading around this is actually calculating our proportional gain and derivative gain through additional logic. Because there is a way to calculate these based on the force that we want to apply and the dampening or yeah, I guess the dampening that we want to apply here. Maybe I'll do that, but I don't really want to touch that right now, because in the end, it's not that different from tweaking these numbers itself. Although I do think that one of the things that we still need to solve, one of the things I'm still not very happy about, is right now the heavier the thing is that you pick up, um, the more we are going away from the values that actually work. So there might be something that we need to do as a function of total weight that you've picked up. I don't know. I'm not sure that that is our problem. The problem, by the way, that I'm talking about, the thing that I'm still not happy about, is that right now, um, our hand feels very dangly. And I was even trying out some things with a test project that I made on stream like last year, but now with the new logic, and picking up certain objects and props, and you could really see that there's like a wobbly sense to it. And I'm not really happy about that. I want to see if we can tune this further. However, I don't know whether that is caused by the angular logic or whether that is caused by the linear logic, because our linear logic is still our old logic that we used to have, which is trying to calculate the force that we need in order to linearly accelerate or decelerate our hand motion to get our hand to the exact position that it should be on that frame. And I was actually quite proud when we originally wrote this. That seemed to be working fairly well. And even now, it still seems to be working very well. So I'm a little bit going back and forth whether it makes sense to replace this logic with a PID controller. However, I think we should try and just see if it works better or if it makes a difference or not. I have a feeling that with the PID controller, we can tune it more. So that is the thing that I want to do this morning. The last thing that I am not happy about, and that I do not understand, because I thought this was something that was actually working fairly well in the experimentation that we did last year, so I'm kind of surprised that it's come back, is that because we're using proper joints between the hands and the object that we pick up, that connection is pretty solid, or should be pretty solid. Now we can see with our little sliders that we created that doesn't work. Although with the sliders, I can kind of justify that in the sense that they are attached to something. So we're really kind of in the worst case scenario there. But the other thing that where I got into trouble with this was I tried some props that were attached to other things, and they started stretching. They started misbehaving in a similar way that the sliders are doing. So there is a problem there in the forces not properly propagating from the hand to the objects that are attached. And I don't know what's causing that, whether that is that we're overpowering the system, or that we're doing something else or forgetting something else that is causing that. So yeah, that is something where I need to do more experimentation. And it might be as simple as what we've done with the hand, is that we might need to turn inertia off when an object is picked up, or something along those lines. I really don't know yet. There's some other things that will be interesting to experiment with, and just see if things work nicer. Avat posted a video earlier today on Discord where he had actually made all the fingers proper joints and objects, so he could actually exert force on the fingers. That's something that I want to play around with. I did an experiment with that last year as well, and that actually screwed a bunch of things up. But I think with the changes that we've done now, that might actually work better. So that's something that I might want to revisit. And especially our collision hand setup actually is really well suited for that purpose. So might do that. We might play around with that at some point. One downside of that, by the way, is that it's going to make collision exceptions a lot more tricky because we will need to create exceptions for all the fingers. And at that point in time, we start getting into the territory that it might be useful to make better use of physics layers. I'm not sure about that yet. I'm pretty sure we can figure it out, though. I'm pretty sure that we can make that work and do things with it, and just see how far we get with that. What else that I wanted to think about right now? I don't know. I think we're just gonna start with doing the linear pit controller, and we're just gonna take it from there and see how far we get. I think after that we'll probably create a new prop, so that we have something that we can pick up that has attached things. I'm thinking actually about something like a ball and chain sort of thing. That should be fairly easy to recreate here. Yeah, so there's some ideas there. There's some things that we can do. That also actually, come to think of it, that also is a nice segue. That one of the things that is still missing here is posing the hands. So one of the things that I still want to do, and actually this is probably something that's better if I just show that. Let's see. Let me just start up. There we go. Let me just start up SteamVR real quick. Okay, there we go. Well, of course, I started just too quickly. I am not patient enough. I started it right before SteamVR actually was up and running. Okay, here we go. Still need to make sure that this thing actually opens on the right screen one of these days. But anyway, here we go. So, hello, we're in here. Very cool. So the thing that is going to be important right now, we are using grab points to grab these things. And besides having the grab points, we actually also want to make sure that our hand is positioned in a way that makes sense. Now, with these cubes, it's we're not really grabbing it in any sort of sensible way. But the other thing, of course, is, and we probably might actually quickly start with that, just to have an alternative. Is I want to show how it works if you have a cube that doesn't have grab points, or an object that doesn't have grab points, so that we can grab in any place. So yeah, let's have some fun with that. Actually, let's make our ball and chain idea work first, just as a sample. So that's actually in the world. Okay, that's fine. So if we go to our table, there we go. Do we want to have the ball and chain on the table? Yes, I think we do. But I want to go and move this box back a bit, and that box back a bit, and that box. Whoops, that's not the box. That box back a bit. There we go. So we have some room there. So this is actually going to start with a rigid body. Oh, I didn't want you there. I want you on the table. Just put you somewhere over here. Okay. So that's going to be our the object that we actually pick up, which needs a collision shape. We're going to actually give that a pill. There we go, capsule. However, you are going to be rotated, probably like this. Nope, that's the wrong one. Rotate around that. There we go. And let's make that a lot smaller. That's too small. And that's maybe a little on the big side. And let's make it a little smaller. Yes. Wouldn't really know what is a good size to put in your hand, but let's start with there. We can always resize it some more. If we want that to be smaller, and then obviously we need that to be a lot shorter. That is too short. Let's make that a 30 centimeter long thing. There we go. Cool. And obviously we need to have another object here, which is going to be a mesh instance. And that becomes a capsule shape, the same. Obviously, we need to rotate that the same. And then we need to size that the same. So that was 0.4 and that was 0.3. There we go. We have a nice little thing that we can grab. That's going to become our handle. Okay, cool. So let's make that ball and chain. Let's go and save that. Actually, before I say that, I actually want to create the next little section. I'm actually going to duplicate that. I'll call that chain link. Link. That is going to move a little bit out. I'm going to make this unique, but we want that to be much smaller. Let's say that for now. Actually, that probably also want to make that a little bit smaller in that way. And this one, make unique. Make the same changes here. Let's see. I think that's still too long. Something like that. Okay, there we go. Oops. I should not have moved you. Let's go back where you were. Then move this one. Nope. I need to move this one. There we go. Alrighty. So now I want to save this. And then not there, but we'll just do that. Actually, I'm going to create a new folder for that called props. I'm going to do a new folder, ball and chain. And I'm going to go put that in there. Okay. Before I continue, I actually want to give this a material. Do I have a nice material for this? Let's see. No, I don't. So I'm just going to make a normal standard material for that. At some point, we'll make something more optimal, but for now, that's good. And I just want to go and up the metallic a little bit. I want to go down on the roughness. So I just want this to be looking a little bit shiny, like it's actual a bit of metallic. Obviously, I want the color to be a little bit more gray. Something like that. Good enough for now. Doesn't have to be perfect. It just needs to be something that we can use. And then let's go and save that first. And now I want to go and save this as the ball and chain material. There we go. And then we're going to go and apply that to our chain link as well. And then we can go and save this as a subscene as well. There we go. So that we can go and duplicate it a couple of times. Do we want to have that on a nice -2? That's probably too much on top of it. Yeah, I need to get a little bit of space there, so that's way too much. That is nicer. So that's going to be 3.2. Let's make that 0.1. Let's make that 0.2. Go. Hey. There we go. Oh, no. Should have been a minus. There we go. Okay, one more. 0.11. Let's do 5 links. That's probably a nice one. All right. Where are I? Oh, here. Actually, let's favorite that property again. I reset some things, so my favorites were gone. Oops. There we go. So Here we have our handle, we have our little links. Now we need to have a ball at the end. Okay, so let's make that another rigid body. Let's give that a collision shape. Actually, I still have them all in here. Let's give that a rigid or a mesh instance. There we go. So now it's going to become a sphere. And definitely not that big, but probably no, a little bit bigger than that. Let's make it 7. Let's do the same thing in here. Sphere mesh. We'll make that 0.7, and that means 0.14. There we go. And obviously we want that to be all the way out here. Let's put that somewhere a little bit nicer. That is probably too much. 7.9. Oh. 7.8. Yeah, that's probably good enough. Okay. Then let's give that the same material. J material. So there we go. So we've got a chain with a ball at the end. Maybe we need to make some of these a little bit smaller. I don't know. It's it's just for fun. So that's going to be called ball. Let's go and also save that. There we go. Okay, with that we've got all that. So now we need to join them all together. So we're just going to do that with a pin joint. Doesn't have to be anything more special than a pin joint. All right. Let's call that pin joint 01 for chain link 01. It means that we do need to move this into position. It needs to be about there. Is that right? Or is it 6? No, so it needs to be right in the middle of those two. 5. There we go. And we're just going to assign the ball and chain there, and then chain link 1. So that links that to that. Yay! All right. Let's just duplicate that. It makes life easier. So this one needs to then move minus 0.11 there. Perfect. But now we get between link 1 and link 2. So that links those two together. Yay. Let's repeat that process. Let's go there. Move that a little bit to there. Whoops. What did I manage to do that? Okay. So that now links chain link 2 to chain link 3. I want to actually move this a bit bigger so that I can actually see what I've linked together. So there we go. Then we're going to go for chain link 4. Minus 0.11. Boink. And we're going to now go from 3 to 4. Okay. And on this one. And that's going to go from 4 to 5. Sweet. And now the last one, which is our pin joint for our ball. Okay, now let's see if that actually makes sense position-wise. Yeah, perfect. And that's going to go from chain link 5 to chain link ball. So in theory, all these should now be linked together. And something that I forgot to check, but I think everything is a kilo. So this thing is a couple of kilos in weight. I think probably this thing needs to be lighter, especially the chain links should probably be lighter. But I'm not going to really care about that. And the other thing that's really important right now is that our resting place has our ball inside of our table. Oh, this is still that really weird issue. Why won't you move? Oh, because no. Yeah, that is on the grid. Oh, I need to do that one. Yeah, I'm just using one. So that little button here, use snap, has a bug in 4.5. I think it's probably solved by now, but in 4.5 still has a bug that sometimes it will work in reverse. And I think it has to do with if it's on when you switch tabs, it's actually still on, but the button shows off. And then when you click the button, all that it does is actually toggles. It doesn't actually check what the new state of it is. Pretty sure that's fixed by now, but whatever. So the important thing is we now have this ball and chain. These are all rigid bodies. Hopefully they work correctly. Hopefully it doesn't immediately roll off my table. That would be very annoying, but it is possible. Something that I often do to prevent that is actually putting an extra collision box around it with a flat side. But let's just see if it behaves. However, we haven't done any XR things, right? We haven't put any grab points on this or anything like that. So in theory, that means that I should be able to grab this anywhere that I want on any of the parts, and it should work from there. So let's just see whether that wants to work or not. Okay, of course, I need to move that into place again. Just really annoying. That is what it is. There we go. Yep. There's one controller. There's the other controller. Here we go. Come on. There we go. All right. So we can already see that our ball and chain are moving. Now, one thing that I forgot to do here is I've actually turned self collisions off, which is why the ball is actually rolling into part of the chain. But I should be able to just grab that anywhere that I want. And now it's not very stable, but it does that. Now, obviously, because my hand is much lighter than the chain, that's probably why it's going silly like that. Still, oh yeah, I can two-hand it as well, and I can try and pull them apart. And this is where you really see that things get a little crazy, and I'm not quite sure why that is. Let's put you down on the table again. So yeah, it's very unstable. I wonder if that is just a feedback loop from our from this. So let's turn that down a whole bunch. See if that makes a difference. No, still, because it's pulling down, it's sort of pulling this thing down, and then because my hand is pulling it back up, and it's sort of oscillating as a result. And I think that is where, where this system is not as good as it should be. And I'm wondering what the best way is to deal with that. Because obviously, when I'm holding it, the weight of the chain is pulling my hand down like that, right? And then the pit controller, the more we get away from where we want to be, the more the pit controller is giving strength back. So at some point, it overpowers it, and my hand moves back to where it is. And then as it moves back to where it is, the pit controller loses its strength because now it's done what it needs to do, and it pulls it back down. So I'm not getting an equilibrium there. And that's where I really wonder whether the pit controller is actually the right way to do this. Because yeah, it is making it really hectic. Okay. And there is a part of me that actually still wants to try my original solution. Now that I know that the inertia was a problem, I don't know. That's still something that I need to work out. The other thing is, right now, because I don't have grab points, it is going to try and grab this automatically. And what I'm doing actually is I'm sending a raycast from my hand down into the object that I'm trying to pick up. Now, wherever that raycast hits the object, that is actually where I pick up the object. And I was actually expecting it to grab the object much lower because that's where I had my hand. So some reason it actually ended up high. So I'm wondering if that raycast is working the way that it should. Anyway, one problem at a time. So the first thing that I want to do is I actually want to turn off exclude nodes on these things, because that is what was causing this thing to self-collide, or it was actually preventing self-collision. That was why the ball was entering this thing. And the other thing is, and I wonder if there any... No, that's again... Because this is one of the things that I'm kind of missing in these joints. And also where I'm wondering whether we have enough support for what Jolts gives us is I kind of want these to be sort of like spring functions so that it does try and keep things. And again, you know, links are pin joints, so that part of it should work fine. Okay, let me see how much that makes as a difference as far as the joint itself. So now you can see that the ball is no longer entering there, but it can pick up the ball here. Now, the ball isn't having these weird rotation issues that this guy has. And I think that is because the ball is nice and round, while this thing isn't. But yeah, we can still see that it's starting. It is behaving better. Although, yeah, if I pull this too far, you can see that it really is starting to misbehave. But, you know, the ball and chain itself works good. You know, that works pretty much how you would expect it to. I should actually be able to swing this nicely and hit stuff with it. Not hitting it. Oh, it's because this is where the ball needs to be have much more weight. Yeah, I'm actually surprised at where it's grabbing that, because I was expecting that to grab it much lower. But those are, well, this really does need to have a grab point, that if I grab that one, whoops. Okay, so I now I grabbed one of the chain links, and it's definitely not happy with that. And again, I think it's because it's trying to orient everything, and there's just this feedback loop that really screws it up. Okay. So again, that makes me wonder whether the pit controller is the right way to do this, or whether it's a tuning issue. So I call this half successful. I call it half successful. Okay. All right. So. I just want to have some fun. Let's turn this off for a second. So now our hand rotation no longer works. Our hand is just going to do whatever the hand is going to do. I just want to see if we don't exert any force on the hand. So you can see that the hand is now no longer being positioned. But so that's still going absolutely nuts. Why? Why? This should just, with the weight of the pill, this should just draw it down. So what is it actually? I honestly don't know. You're on the ground now. It's still rotating. So yeah, that makes me really wonder what exactly is causing that. Now, let's go and turn on visible collision shapes. Let's see if it's reporting collisions between the hand, because it's not supposed to, but let's see if it's reporting collisions between the hand and the okay, so that is indeed what is expected because it's reporting collisions. So why? Oh, there we go. No, it doesn't seem to have collisions on the hand, so that's working fine. But why is it? Because there's now a joint between the hand and that capsule, which is no different from, you know, the joint between all these shapes. You can kind of see, you know, I don't know if you guys can see that again. The collision shapes of the actual hand. Why would it do that? Because again, I would have thought that, okay, we're not applying any rotational force on the hand. We're purely applying positional force on the hand. And we have the pill pulling down on the hand. So you would expect to have something that I can use here as a prop for that. Let's do this thing with my battery. So you would expect that, you know, I grab that and that would just pull it down. And then it would just find an equilibrium there because I'm not applying any additional force. It's just, I've now got a heavy thing attached to my hand and that would pull down the hand. But that whole flipping around like crazy, I don't know. It doesn't make a whole lot of sense. Now, again, one thing that we did do is that we removed or zeroed out our inertia on our hand. And this actually I can remove now because I'm now actually, have I removed that yet? Where are you? Validate property. So we're going to go and take those out because I want that just to be settable. I'm happy for that just to be configurable now. Where's my ready? So with that, I should no longer have to do that. And I should be able to yeah, so that is, oh, yeah, combine. So I don't have any angular damp and I don't have any linear damp except for the default. So I'm getting obviously my default physics. So my default linear damp is 0.1. My default angular damp is 1. So that should be applied to those now. Which is fine. So we've actually, oh, and center of mass mode should be, ooh, that's on auto. Could that be something that's mass? Yeah, okay, that's just calculating the center of mass. That is not calculating the inertia. So that's fine. That's just calculating the center of mass of. Do I want that actually? Or do I always want that to be in the middle of the hand? I think I would just want that to be in the middle of the hand. Hey, Wild Robot, how you going? Okay. Okay. System and center of mass. I think for the hand in this case, that makes a lot of sense. Which means that I do want these two to be, in my list of, hey, we're taking care of these. You know, why would you do that? Sometimes the autocomplete is really annoying. There we go. Okay. Oh, what do I have that as options? Oh, yeah. Teleport and disable. So I'm gonna have to add our angular error. That is just if it's not collide, then we hide those. Yep. Cool. And I guess I never did the force fall off, but we'll deal with that once we figure out what else we want to do there. Okay, so that does at least the center of mass, but I don't think that makes a difference. Well, that's what we've been trying to do for the last couple of days. And this is actually no longer Detmoja's attempt, or an attempt at reproducing what he's doing. Although, again, he's doing similar things to me, and either he's having similar problems and solved them, or he's doing something different than I do, not running into the same problems as I'm doing. Go away. It's been a little while since I last looked at all this. Now, here's one thing that's really cool. Is we are using modifiers to position our hand, and I'm actually doing those, if I remember correctly. No, I'm adding them to the skeleton node. Where am I adding the skeleton node? The hand mesh. I'm doing this wrong. Maybe. Yeah, because we're always adding the ghost here. So where's the stuff we're adding? Oh, it's over here. So we got our hand scene. Instantiate a hand scene. We're adding that to our object. And we get a hand skeleton. Very cool. Then we get a ghost mesh, and then we apply our modifiers to our ghost mesh. And then on our skeleton update, we just call it when all our modifiers have been applied, we copy everything onto our main hand skeleton. Although I'm doing some extra funky things here. Oh, stop doing the little. I'm not quite sure why I'm doing this. I probably have a good reason for that, but I am not sure why I'm doing that. Again, it's been a while since I last looked at this code. However, the reason why I'm being distracted by this is that this is copying all the positions from the ghost and onto my actual hand skeleton. And what we can do instead is use that to drive additional finger joints and actually have the finger joints to be separate rigid bodies, and we can move those, and then we can copy those over to to our actual hand skeleton. So we have the ghost hand always in the position according to our tracking data slash whatever else we want to do. So basically, the ghost hand is always in the position that we want the hand to be. But instead of copying it over to the hand skeleton, we can add some physics there and make that work. That's not something that we're going to deal with today. But that is something that I do want to get to at some point in time. So that is something that I still need to look at. Okay. But nothing in here. Oh yeah, I wanted to look at how does the pickup work. Or that's in the pickup itself. That's why. And again, I wrote most of this code a year ago, so I'm trying to remember how we did things. Okay. So we got a closest grab point, so that's where we need to have a look at whether our raycast is working properly. So we can pick up rigid bodies or we can pick up physical bones. Now, physical bones is what drives skeletons. So again, what I was just talking about is we can actually have that do the hand stuff, which is really cool. And then here we're adding a generic 6-staff joint between our collision hands and the object that we picked up. Okay. And that's the other thing that's going to be interesting when we start doing this. Because if we grab something where we have posed the hand for those fingers that we've posed, we won't want to have the animation working. Okay. But that's a problem for later. That's a problem for another day. Right now, we need to figure out, we're creating this joint. We're joining our hand to the object that we're picking up. Now, one thing that's important here is that we do not do collisions between the hand and the thing that we are picking up. So just like in the ball and chain, we're basically creating, in this case, a pin joint, but should I actually be creating a pin joint here? Because I'm not setting any restrictions on the 6-staff. No, that's why I'm not using a pin joint. I'm using the 6-staff because I want the orientation to be constrained. And again, is that why we're getting the oscillation? Is there, would there be an order in this? No, it shouldn't be. Because one thing that I really wonder about is if the weight of this matters. So let's say that we drop the weights of this down. I want to do the same for the links. I just want to make the ball heavy. These should even be lower than 0.1. I just want to make sure that the weight of the object that we're picking up is much lower than the weight of our hand. And then the ball can actually be a bit heavier. All right, let's see what that does. And again, I'm just kind of hoping that we get to a point where, come on. Okay, so where, now our hand is still, and this is the other problem that I just don't get, is now that the ball is really heavy, it is just pulling the whole thing apart. Well, there's no reason for it to do that. Yeah, I know the ball is heavy, but why would it pull the pin joint apart? Hinge joint only goes over one angle, but that's not what we want at all. Let's see, what other options for joints do we have? No, we don't have a ball and socket. We're not doing a slider. So the other option would also to be using 6-dogs here. But then saying, okay, we have a linear limit of 0, but we don't apply angular limits. It's worth trying, seeing if it works. I don't know. Well, seeing I've pretty much got them all. Can I just do change type here and just do make them general? That's keeping that. Yeah. Just gonna rename that to joint. So the linear limit I want to keep, but the angular limit I want to turn off. Keep all that the way that it is. Okay. Right, let's do the same thing to this one. And again, this could just work with pin joints, but oops. And this could probably, we could probably see in which direction it should not be able to rotate, but I don't think that matters. All that I want to make sure is that we have a linear limit so that the things stick together. But as far as I know, this is exactly what a pin joint is. Okay, let's see what difference that makes. Although I can't believe that that would make any difference with how the top thing behaves. See, it's still. It does not like that at all. But yeah, it's still just pulling it apart. Why would it do that? I'm going to turn off the visual collision shapes again because that's just annoying. I can't really see what's going on. Can't see. Okay. Did I turn it off? Yeah, did. All right. So so it's behaving exactly the same as pin joints, which makes sense. So I think that we are going to change this back to pin joints because that just makes much more sense to use. Pin joints. Pin joints. Oops. Okay, so I want to try something else. All right. So I'm going to do something funky. What I'm going to do is I'm going to create a static body. And I'm just going to give it some bogus collision shape. Really small. See, now that one's working the other way around. Just want that to be somewhere over here. I'm going to go move you somewhere over here. Boom. Okay. Oh, of course I did. All right, let's try that again. Okay. That looks nowhere near where it should be. Okay, here we go. Actually, it's going to go like this. All right. And we add another pin joint. Can be slightly down. That's fine. And we're going to give that the static body on one side. And we're going to give it the ball and chain on the other side. So that creates a pin joint between the static body and this thing, which also means that I actually want this one to rotate like this. And I'm actually want to move that like that. And obviously I want to move my static body up a bit. There we go. All right. Pin joint should be there. Yeah, cool. Doesn't have to be precisely above there. It's actually nice that it's slightly off-centered because that should move it slightly off-centered. The reason I'm doing this, and let's also go back in here and where are we with this? Let's take that out again. But the reason I'm doing this is we're now going to have our ball and chain dangle from our static body. And it's going to be free to dangle there. I'm going to be interested to see whether that is going to pull apart the chain. Because what I don't want to rule out is that what we're doing with our physics hand is the thing that is causing all the weird physics stuff. But yeah, so as you can see, that behaves exactly the way that I'm expecting it to. Now, I should be able to interact with that, so I should be able to move it. And that is fine. But again, when I do this, you know, see that it immediately screws up the whole chain. All that I'm doing, oh, now it's slowly correcting itself. Oh, come on. Now it's back to what it should be. But the moment that I'm grabbing this, it starts to really... Wow, it's not even doing the... Oh, that is weird. Is that because I took out the inertia? Is that why? Why would it do that? Because again, I don't know whether it is the rotational stuff. Oh shit, you guys couldn't see that. All right, let me oh, and it's actually in a place that you guys can't even see it. All right, let's redo this experiment. Let's move this first of all over here. And now let's go and make sure you guys can see what I'm seeing. All right, let's redo this. I think you guys can see a little bit more of the chain now. Probably should have moved it a bit more forward so you guys could see more of the chain. I need to make something to enable it, the camera to move. So when I do this, it just goes and it pulls it completely apart. Now, if I try and go grab that, okay, now this is interesting. So now that I've grabbed the end of the chain, and I guess it's because of the ball, but now that I've grabbed the end of the chain, it's happy. Now I can still pull it apart. You can see that goes really, really bad. And that's something that I'm wondering if we can fix that somehow. Because I shouldn't be able to pull it that far out. But this is working more properly. So why does it not like it if I grab that initial thing? Where it's immediately, I don't know if you guys can see that, but it's immediately pulling that first layer apart. Of course, I'm not seeing where the static body is, so I don't know if it's still pulling it apart in a weird way. That's still pretty cool. I can still do all my two-handed logic. That bit is working correctly. Well, okay. We've stalled enough. I'm actually starting to get convinced, seeing that we were having problems regardless of whether we are enabling or disabling our rotational logic, we are getting into trouble. So, hypothesis. The code I've written here is written in such a way that I look at how far away my hand is from it's where my physical hand is from where my virtual hand is. And I'm calculating the exact force required for that hand to move from where it is to where I want it to be. Great. That's exactly what we should do. Now, one thing that I discovered when I wrote that logic originally, which made absolutely no sense, is that I'm calculating that based on the weight of my hand. And that logic is very precise. It will move my hand exactly to where it's supposed to be. Now, when you grab something heavy, you would expect to need a much greater force in order for that object to move from where it is, from our virtual hand object, to where it is, to where it should be. But it doesn't. I can apply the same amount of force as before, just using the weight of my hand, which is set currently to 0.4 kilograms. And with the same amount of force to move my hand, it can drag anything from, a 1 kilogram object to a 20 kilogram object to a 100 kilogram object, which is kind of part of the problem that we have, that we don't actually want it to work that way. So there's this weird thing about that it isn't applying that force in a way that makes sense. And I don't know whether there is something behind the scenes that the mass was already being adjusted or whatever it is, but that whole logic isn't working as I would expect. So my hypothesis is, because I am applying the exact force to move my hand from where it is to where I want it to be, and because it's now attached to that other object and is therefore moving that other object that same distance, whether that makes sense for that object or not, it is going like, panic. So the big question now is going to be, if we instead do the pit controller thing, where we're applying a force to not immediately, but somewhat more slowly move it from where it is to where it should be, would that fix it? Because again, the further away we are from our from where we were, the bigger this force. And I'm guessing that at some point we're just overpowering the whole system. And with obviously a pit controller, while we are increasing the force depending on the distance, we are not being immediate. And one of the things that is definitely a part of that, and which is going to be important with that, is if we grab something and we pull so hard on it that are like what I was doing with pulling the ball and chain apart, we actually don't want it to pull apart. We want to be able to specify a maximum strength that we can pull at. And once we reach that maximum strength, we are not getting our hand to the position where we actually are. And when the distance between where our hand virtually is and where our hand is in real life becomes too big, we can trigger a let go. We can say like, okay, you're pulling very hard on that chain, but that chain's not moving. Now you just lose grip of the chain. So there's a good chance that that is part of why this is doing what it is doing. Now, one thing is that I did do that max force here. Yeah, that is probably way too high or something. I don't know. But yeah, I think it is about time that we simplify that. Oh, my coffee is getting cold. So yeah, let's change this over to a pit controller and see if we can start tuning that in a way that actually makes more sense, that we no longer overpower the system. Again, I'm still a little worried that, everything that I've tested so far with this seems to suggest that, do we still need this state? No? Okay. I'm going to say, actually, that's, excuse me. Yeah, I do need the state because I'm getting my gravity. No, I'm not using that anywhere here, am I? No, I think I'm going to go and do the whole thing as if false, hold subject. Okay. And again, talking about what Demonjazz and me do differently is in his original implementation, he was just applying a set force instead of, trying to do this funky, like, let's calculate what it should be sort of stuff. All right. Cool. Let's see indeed how well that works if we just start using a pit controller. All right. It'd be so nice if this finally starts working the way that I hoped it would work. All right, where is our pit controller defined? Here. So we've got our angular. Oh, we can already remove that. We're not going to bring that back in. So obviously that is going to be all our stuff. All right, what am I using this differently for? Am I just doing that to hide the original mass value? I think so. Does that still make sense? I think I'm already going to take that out because that was an old experiment, actually. So let's clean that up already. You don't need to be there. That also means I can take that one out because we're going to go apply mass the way that it was. We can take that out. Okay, now we can see mass is indeed 0.4. Which does overrule the default, which means that if someone adds a collision hand for the first time, it's going to be 1 kilograms. Maybe we're just going to go and see how well it works with that. because I think in our case, we don't really care about the weight of that. Okay. That was a little bit dangerous to change that, but we'll see if that does what I want it to do. Okay, that is no longer a thing. Now, because originally I did that hand mass thing because I was actually calculating the total mass based on whatever we were attached to, but no, that didn't do anything. Okay, so export var linear. We are going to call PID because it is a full PID controller. Linear PID controller. Okay, so eventually we're going to do a preload there, but for now we're just going to keep that the way that is. PID controller that manages the linear motion of our hand. Okay, and that means that obviously eventually we'll get rid of some of these things. And we're eventually also going to have a oh yeah, I actually already have that. So I'm already saying if the distance between where my hand virtually is and where my hand physically is more than a meter, we're going to actually teleport the hand, which means that we're just moving it regardless of physics. And I already have like, okay, when that happens, drop whatever you're holding. Although there's some exceptions that we're going to need to do there, especially if we actually teleport our player. We don't want to drop everything that we're handling. We have in our hands when we do an actual teleport. So there's a difference in naming there between actual teleporting a player and teleporting in the sense that we're teleporting our hand from one location to another. Okay, so we're going to create a new PID controller there. We're going to go and save that. I guess in there. So that is our default hands linear PID controller. That's what that is going to be called. Okay, cool. Which also means that I should now just be able to do this. And call that linear PID controller. Okay, now if I come back here, let's see if my right hand has gotten that or no, there we go. Cool. All right, so we're using that same one and we can now change these values. We're gonna just start with a proportional gain of 1. We're gonna leave the rest alone and just see how far do we get there. Yeah, let's do that as a helper. Can I type? Okay. Controller is near. Oh. No. Oh, okay. Sorry. Never mind. I thought it was somewhere else. That's in the stage. That's for to create or to control our sliders. Got a little confused there. No, we can just go and do this. We can go to process over here. That's all our old logic. So here, let's go if pass, and here we're going to say new logic for rotation. There we go. All right. So in this case, our linear PID controller. Okay, so that still needs to have a 3-DOF version. So let's go and have a look here, because we want to be able to do this with float over vectors as well. Okay. So why is my phone being so annoying? What is it with Apple being You know, sometimes it unlocks the phone properly when you look at it, and sometimes it says, no, not gonna tell you what your notifications are. No, that's not what I wanted. No, that's definitely not what I want. One thing. Well, now I lost all my notifications. How great is that? Just want to see if there's anything important that I'm missing here. Those are all old. No idea. I'll look at that later. Okay. So. Those are all export stuff. So we are going to change this to a vector 3. And that's going to be a vector 3. So this is the same changes that we made before, and all the changes that I ended up removing in the end. However, in this case, we do want to keep both the calculate and the calculate vec3. So in this case, we're going to say for error, that works fine. Here, we're purely going to modify the x. Let's say x. Let's say x. Oh, no, saturation does not need to be a vec3. Indeed, that is not going to go like that. Then here, error last dot x, value last dot x. And I think that works. Okay, so now we need to make a vec3 version of this. I'm going to call that calculate vec3. Now this is going to be a vector 3. And this is going to be a vector 3. And it's going to return a vector 3. So in this case, our error is going to be the difference between target and current. And that obviously is going to be a vector 3, but I need to now make sure that that is the other way around, or that doesn't work. And here we can do that, and we should do a var saturation vector 3 is vector 3. There we go. There we go. That should work. Where is it complaining? Oh, it's much further down there. Okay, cool. So you get with too many requests. Where are you getting that? Okay, that should be fine. And here as well, actually. Okay, that can be like that. Okay. Which means I actually kind of want to do this as well. There we go. All right, so that obviously needs to be a vector 3. Okay, cool. And that needs to be a vector 3, but that one needs to be the other way around. I think that I need to do that here as well. Hence, it wasn't complaining about that one. Because if you try and multiply a float with a vector, it probably does something crazy. Anyway. That, in theory, should do everything the right way. Now, obviously, that means that we can't combine calculate and calculate the vec3. You either use calculate if you're just working with a single value, or you use calculate the vec3 if you're using a vector. but that should now do a proper PID with the vector. Oh, why is that suddenly? Okay. Clear. Okay, that's erroring on something. Oh, that is probably because I'm in the middle of doing this and there's an error in there. And that is why I'm getting those, because this script is no longer compiling. Okay. So our calculate vec3 takes our current value and our target value. All right. Cool. So here we should be able to see what our current value and our target value were one times. So it's target origin and global position. Cool. All right. So this should now give us a nice PID value to go from our from our global position to our so do we need current value, target value? Okay, I need to turn that around. Target value is lost. So let's go and have a look at that. All right. So with that, I should now be able to go boom, boom. Yeah, no more errors. Yeah, if you were, where are you getting a too many requests on Git? That'll be interesting to know where that's going wrong. That's not supposed to happen. Unless GitHub is having issues. All right, so now we have a PID value for this. Very cool. So we're just going to be using that directly for our force. So boink, because we're going to assume that we're going to control our PID values to actually give us a proper output for that. However, we are obviously going to make sure that we have a delta applied there. And that's actually one of the things that I'm still sort of wondering is, does that make sense? Because, well, it makes sense for this, because here we're dividing by delta. But for our error value, that is already I don't know. I wonder about that. Yeah, should make sense. We'll see. Anyway, so we're going to apply that for. So we're going to assume that our PID strength, it's not just calculating how much we need to move. Our PID values are eventually also going to, apply that as a force. All right. We've got a value of 1, which is probably way too little for this. So I'm expecting right now not to get much movement. Of course, it's probably disabled that again. Are we still in? Nope, we are not in Steam VR anymore. Yay, Steam Link is timed out. All right, let's go back in Steam Link first. Yeah, I know. I can start up Developer Hub and I can disable the proximity sensor, and then I wouldn't be dealing with it. Am I being too quick? What? Why are you not going into? Oh, session mismatch. Yay! Connect. Okay. Play. I want a headset that I can just keep on my head while I look at the screen. Okay, we're hitting a breakpoint. Yay! All right, I missed one. Oh, that is a. Oh, come on. Oh, that's important. Oh no, that's not important. X. Up. Play. Yep. I was kind of expecting that. Okay, so this is the 1 meter thing, right? If I drop more than 1 meter, I teleport back to where I should be. But this is meaning that my pit strength is not enough to overcome gravity. That is funny as heck. All right, so, oops. The nice thing about this is I should be able to actually tweak that live. Where are you? Character. No, that's not what I want. There we go. Okay. Equal hands. Blink, blink, blink. Okay. What if I go for 10? Not enough to go for 100. What if I go for 1,000? Okay, either way, this is not applying or we have a bug in the code somewhere. Oh, no. All right. These are ridiculous high numbers, and I do think, starting to wonder if I should be applying delta or if that is a mistake that I'm making. My hands are stuck to each other. However, it's starting to get into the value range that I want. Okay. So let's give it some. Come on, stop. Are they attached to each other again, or? Yeah, I think they're attached to each other somehow. Let's restart this. All right. Has it saved that? Yeah, it's saved that. That's so cool about this is when we and I probably can edit it actually over here. I don't actually need to be in the runtime thing. Okay. Oh, why are they moving in sync? Something weird is going on here. Oh, dang. Okay, that is probably also a problem for my hand rotation. Oh, I'm stupid. And for some reason, oh, because in this case we're no longer storing stuff here, but I'm still going to make it local to scene to save that. So because we are doing this stuff, we're sharing the same resource, and therefore it's applying the same changes to both hands. Okay, that was a bit dumb. All right, so is this now? Okay, I think maybe our velocity of this is just too much. All right. Whoa, what is that? Okay, so we're definitely still swinging around too much. Okay. Actually, before we do that, let's go and half this. I just want to see if we might have overdone that bit. And again, I might be doing something wrong with the fact that, okay. Yeah, we somehow we have the hands bump into each other. All right, well, we're definitely seeing this oscillation. All right, hold on. I need to look at how this looks inside because, oh, come on, because I'm not really getting. It is hilarious to see this though, but yeah. All right. Huh. So now it's gone to hand tracking. Okay. The thing is, I'm now got. Hold on, local. I'm guessing now if I no, what? I'm guessing if I now change this, does that immediately have an impact? It does. It's getting my hands stuck to each other again. This is so freaking weird. Come on, let go. Let go of my hand. All right. This is just so ridiculous. My hands just got joined together somehow. Come on. Oh yeah. I need to press the button. All right. I don't know. Okay, I think I already know what's going on. Because yeah, I've ticked it as local to scene, but they're still the same scene. Am I actually getting oh, we can verify that real quick actually. Because if I go in here, oh, well, there were sort of individual. If we go here to remote, and I go in here, and I go in here, and I go in here, and I go to my left hand, and I go in here, and I see that that's 5,000. If I make this 6,000, and I now go to my right hand, that has also gone to 6,000. So it's actually not. Because I'm resource sharing, it is actually not creating. It's not creating individual instances here. Unless that is a problem just in the editor, that's also possible. All right, so I think what I need to do, let's go stop that. What I need to do is I need to get into my ready function here. And then after here, boom. Make sure our pick controllers are make no. Resource. There should be a make unique thing there. Maybe that's just a duplicate then. Okay, I do want to have an if pid. Okay, and then we do the same with our Angular PD controller. It's Angular is Angular duplicates, and I actually want to make sure that we do a true there. Oh, forgot the colon. There we go. Okay. Let's see if that makes a difference. That would be very hilarious if that was indeed the reason why my hands go. So here we go. Okay, now they are behaving uniquely. Okay. Now they're behaving independent of each other. Okay, so, all right. Cool. However, because we're now doing this, we're now duplicating them in runtime, we're not changing or influencing our actual scene. Good. The downside is it's now harder to do that. Now there is a part of me that says maybe we shouldn't be doing that for Angular PD controller because, and actually let's make a remark here. We're just going to do this. Don't need to do this. Angular PD controller, it doesn't retain states. But in case we ever do add that into our PID controller, I want to do that. Which means that I don't actually care about these anymore. That's now overkill. So we just duplicate our linear PID controller because it's not just, and this is actually where I'm cheating a little bit, is technically this is not a resource. This is a resource plus. So if this was a resource, you shouldn't normally do this. But because we're actually having logic inside of our resource, which is breaking the rules a little bit, absolutely breaking the rules here a little bit. Yeah, I'm doing it that way. But creating a copy of this is pretty. It's not like there's overhead in there. Anyway, I'm gonna actually turn my derivative game back off. I actually want to start playing with my integral game first. Let's actually put that to 10. And let's see what that does. Okay, so we still got our big swings. So somehow our hands are hitting our body and causing us to jump. That's the raycast. The raycast is probably hitting on the hand. So when I put my hand underneath my body tries to jump onto my hand. We have to fix that. But that's for another time. We're not going to worry about that too much right now. But that is funny as can be. So yeah, see, that's just what's happening is we are raycasting on our hand and we're jumping. Which is going to be interesting because that also means, that if you pick something up, we could still probably raycast on it. We could put it under our body and jump up. So yeah, we're going to have to figure something out for that at some point. Let's up this a lot. I'm just not. Oh, okay. Let's make sure our integral saturation isn't so low, because probably it just never did anything because it would never reach that. Now, so yeah, we're still orbiting too much. So I'm guessing that it's actually our derivative gain that should dampen that, but I've always suspected that we need to actually make that a negative value now, because that's actually making it worse. Well, it's interesting as I move my hand down. Oh no, there it goes. It's all in timing. Oh, that's because it did the teleport, and that resets it. Okay, so I want to go and see what happens if I make my derivative gain negative. Make it a slowdown. Okay, that's starting to look like something that we want. It's not there yet, but yeah, I just want to make sure that we're actually not. Yep. Okay, let's up that to a bit more. And I actually want to up this a little bit more. But actually thinking that we might need to make that our integral gain a little bit more. Ooh. Yeah, that is definitely worse. Let's actually make that a bit less. We can put it back to 6 and see what happens then. Yeah, just makes it worse. Okay, let's go way up on you. It still makes it do nothing that really makes sense. Am I going the wrong way with this? That's the problem. Let's go way up with this. All right, I need a way to easily tweak this because this is way too much trial and error. It's just losing track. Okay, what am I doing wrong here? Trying to think of a way that we could make it easier to debug this. Because it would be, it would be nice to see if we can graph this out or something. All right, let's go back to this. Okay, so that is, I just want to see what happens when we up that. Actually, let's first go lower. What happens if we go lower? Is it going to find an equilibrium earlier? It's a weird thing that, even though, I just want to see, just what are these values doing when we adjust them? Okay. So that's actually having a fairly serious effect. Let's double this. Okay. This is really becoming trial and error at this point. And I'm not so happy about that, because I can't clearly see what the impact of everything is. Yeah, I really need to do something about that. Okay, so once it's at the right spots, it actually works. It's the initial thing when I go too much. And again, why? No, that was definitely working. Yes, now on the teleport that it All right. I think those high numbers are just needed because I'm doing it multiplied by delta. I think I might be. This is the thing that I find it really interesting is when the body jumps, it actually moves the hands fairly okay-ish. God. So strange. So we're doing everything internally with our normal error values. I don't know. I don't know. I don't know. I don't know. How am I going to make it easy on myself here? And again, there's a part of me that wonders whether that makes sense. Let's just double check this. That's time dependent. That's exactly what I needed. So that is good. Mm-hmm. Because there's a part of me that wonders, do I need to? No, because that's the whole thing about this. So this is going, yeah, that's our rate of change. That. I'm really wondering if the extra times delta that I'm doing, I'm starting to think that that is actually wrong. Because no, because that is already. No, it has to be. It has to be. The problem that I have is for the derivative and the integral, we are changing the values based on our velocity in meters per second. Or error in meters per second. which means that we would have to bring it back down to something that is localized. Else it wouldn't be frame rate independent. Which would, result in these high numbers because everything is then divided by 90. Although even then, our hand is 1 kilogram, so it wouldn't take that much force to move it. I don't know. That's also the reason why we have these so high. This one we do negative velocity times that. Do I negate it here? Yeah, already negated here. So I'm double negating. Okay, that's at least one thing that we are doing wrong. Okay. Oh, of course I need to put this on first, or else it's going to disable inputs. Here we go. Oh, that immediately makes a big difference. So yeah, it helps if we actually have the derivative in the right direction. It's not following fast enough. Okay. Oh, that is hopeful. So let's up you by a lot. See what happens. Okay. Okay, I was expecting that to make it follow a lot quicker. Okay. Make that even more. So to see what I really want to just turn that value off. Okay, what are we getting now? Okay, that's following it way more quick, but we need more dampening, so that's what our derivative does. Okay. It's crazy the amount of values that we have here. I'm really wondering if we're not overpowering everything, but it's so laggy. Why? Okay, let's make this a lot and see what it does. Which way around do we go? Oh, come on. Nah. Need to fix that. Doesn't really seem to do much other than Alright, so is it increasing this or let's take that out and see what changes then. Okay. I think we might have overdone our Chico then. Okay, let's go and halve that again. This is not bouncy. Oh, sorry, guys. Okay. So the really weird thing is, well, maybe not so weird. And because of gravity, it's actually pulling that down. All right. What I actually want to do right now is, oh, here. I don't actually really care about I in this case, but okay. You see how little this is. That actually is quite substantial. But we're still doing that times delta eventually. So that would be a fairly small force. So 1775 divided by 90 frames per second is, so basically we're applying about a 19 Newton force in the up direction. Well, for our 1 kilogram hand, we're applying something downwards. Yeah. Actually, what I then probably want to do is I'm going to say that 90 is going to be our reference frame rate. So that we actually get this into a little bit more decent values. 20. And I really should be doing that for our angular as well. All right. Let's see. Oh, that's looking good. Hold on, let me see it inside of that set. And a slight bit of bounciness, slight bit of overcorrection. Okay, what does it do when I pick something up? That's actually working better than it's ever has. The thing that surprises me most is that the rotation force is now actually working properly. So I actually think that our movement was, this is still too bouncy, obviously, Still want to deal with that, but that is looking much better. It's not, see that, it's not pulling the whole thing apart. It's a little bit, because I am eventually able to put too much force on it. So I do want to have a max output on this at some point. And then obviously, you know, we want to have a much smaller teleport distance. All right, we're gonna have to have a second ball and chain, one that doesn't hang off of that, so that we can actually play around with that properly. Does that actually mean that I can now? No, that's still pretty much having the same problem as before. Although I don't really get why. That doesn't make a whole lot of sense. But yeah, whatever. Still, that was my computer. Can I reach you? Hey. Yep, because your grab point is wrong. Okay. Oh. Yeah, I really don't like this box actually having grab points. I think I'm going to make some different objects that actually have grab points. I might actually remove the grab points from the box, because it doesn't make sense that I'm not picking it up from the actual place where I'm touching it, but that we're going to go to where the grab point is. So that's definitely something that needs to change. But for that, I need to have some objects that actually have grab points. Okay. So we're getting close to where we want to have this. I'm probably going to add a little bit of integral after all. So let's just be very conservative with that and see what happens there. Still a little on the laggy side, but not too bad. I've also got the lag obviously when we're moving, which really sucks. I think one of the things that we can do is let's up this a bit more. Let's see what it does. Much closer. Let's get crazy with the values here. Go all the way to 10. Considering that we're already multiplying by 90, that is we're really getting some overpowered power now. I still have, but that is definitely lagging behind. What does it do with this? It's not overly bouncy anymore, but still a bit bouncy. I don't know what would feel natural. That's the thing. You know, I do like the two-handedness that is just completely automatic. All right, we're gonna remove the grab points from the box because that's actually starting to annoy me. I can probably just disable them on the boxes. I think I added a disable option in here. Yep. Okay, let's just disable them and see what happens. So yeah, now it just grabs wherever I grab it. Okay. Not super precise and moves it slightly, but still kind of like that. Obviously, you know, finger placement is wrong, but that's all right. But yeah, handling the box is actually quite nice, and it just really nicely balances it. Oh, not quite sure what happened there. Oh, my hand probably just got stuck inside. Yeah. Obviously, you know, when the hand's inside and let go, then it's sort of boink, boink. So yeah, I don't know. It just feels so spongy, and that's something that I really don't like. But I'm not quite sure what to do about it. Mr. Diogos, that is very true. That taking your headset on and off all the time is super annoying. Um, you know, it's where I'm still, you know, it's in the background if you guys can see it, but it's where the Acer headset was really nice. It had a terrible headband. Mine headband is actually broken, but the fact that you can flip up your display, so nice. Um, so yeah, it's it is a problem. Hey Sam Farmer, how you going? Yeah, the Meta XR simulator helps. It definitely allows you to do quick iteration. Of course, the sort of thing that I'm doing right now, the simulator does not help. Yeah, you can use the controllers with the simulator, but it's still not the same as being actually able to look around properly and see what's going on. Anyway, that bit works. There's some more things that we can probably improve there, but I want to add a second ball and chain here. Oops. No, I want you over there. Why is it not allowing me to put it over there? I don't know. What? Okay, that is going really funky. Let me just go boom, boom. That sometimes helps. Whatever. Can I remove the box back over here? Oh, it's really not liking that. Actually, what I really want to do is I want to grab that one and that one. So that's my. Actually, I can probably move that one over here. Actually, I want to go like, no, not on the pin joint there. Yep. And I actually want to put that there because that no longer has anything to do with the table. So this is going to be all and chain fixed. And now I can just call that one, move that one over there. That one can be normal. But this one, I now want to go and just put on the table again. So that we have one that we can pick up. So we can have some fun with that. Okay. We can see if that works better. All right. Now left collision hands are really well. That still needs to be a bit. It's going to up this a whole bunch more. I'm going to put that to 200. Okay. All right, so that's really moving very closely, even moving like this. It's really staying nicely where I want. Oh, that one immediately fell off the table. It's not quite what I wanted. Now, obviously, because I've got that pretty strong, I can pull things quite a lot. But I probably want to make that a little bit lighter. Well, that obviously is now a lot less spongy. But now with 10 kilos, that's a little bouncy because it is heavy. Yeah, I'm not quite sure about that yet. I might have gone too far now. So if I go and put you back to 10, I want you to actually be higher. Let's see what that does. And again, this is where I'm really sort of concerned that when we're holding something, so we can at least see that this now works properly, way better than it did. It's still, strangely enough, pulling that in a way that I don't get, even though when we're on the static thing, and this is where I just think that there's something not right with how the physics here work, because this again, oops. Okay, so again, I am bouncing myself against that, and I'm getting launched. So that's definitely something that I need to figure out something to do about. Yeah, that's actually weird because I'm a character body. So why would my character body be launched like that? Just because another object enters my collision chart. That's really weird. Well, you're on the ground now. Nice. We need a remote fetch thing. Need like a little gravity gun from how half of Alex does that. So yeah. Nope, thank you. It's better. It's still a little, but it's, yeah. So the my problem is, from everything that I can tell, the way that it seems to work is my hand object, the rigid body on my hand, gets what do I do as a physics? Do I set that at all? Not ready. Could that be part of it? Because the thing that I'm thinking about is the way. Oh, there's a little bit of thing here. Oh, good things. I found that it's. Wait. I found that it does not work with the compatibility renderer. Yeah, that's right. The XR simulator on macOS only supports the Vulkan renderer because there is no OpenGL on Mac. Mobile mode is best for lowering expectations. If on light particles that couldn't be appreciated in the meta. Okay, that's not good. Are you using APK export to test, or are you using? No, this is all SteamVR, Steam Link. It's would be way too slow to keep pushing APKs into the headset. Anyway, so the physics priority issue. This might actually have something to do with what we're witnessing here, because the thing that I am, keep running into is what I believe is happening is the physics on our hand are applied. So I've got my hand here. I'm applying a force. The hand is now moved over here. All right, done. Now it turns out to be something joined to my hand. So now the physics engine says, hey, I've got this thing joined to my hand. I need to move that to the place where my hand now is because of the joint. So it applies whatever force it needs to do that. And I think that is where things get weird. Let's first start and see, okay, what happens if we do not do the physics priority thing? The whole thing of the physics priority was to make sure that when my character moves, that my hand eventually moves with it. So this will still be good. So we can see, oh, there is a bit of more lag there now because now we're a frame behind. Oh, I didn't mean to drop you. But that still pretty much works the same. So that's, I don't like that thing fell on the ground because I actually want to do something with that. So we need a box to put it into. Okay, let's move the ball and chain a little bit more. Oh, this problem again. A little bit more center on the table so that it's less likely to drop off the table. Okay, so how well is that going? No, that still has that problem. And we can just see everything stretch out. This is such, and I know that it didn't do that at, at some point in time. So I'm really wondering if something changed in the physics. Okay, so our priority thing did not change the behavior as far as that is concerned, but our priority thing did. Okay. No, it's no different. It's still lagging behind my movement a little bit. That's the other thing that I just don't have a good fix for. Because the player body is not attached to the hands. So the player body moving does not move the hands. So the hands need to catch up to where the player body is moving to. And there's a notable lag there. I just don't have a fix for that. That is just the problem with physics hands. Well, I have a fix in the sense that it can do a move and slide, but the problem is the move and slide completely breaks joints. So again, the thing that I don't get is that I had the joint stuff working at some point in time. Oh, you guys couldn't see what I was doing. I'm so sorry. So yeah, what was I doing? Yeah, no, I still had the same problem. I don't know if you guys can see it, but the moment that this drops, it just pulls it all apart. And again, I think it is because it kind of moves things. Well, actually, I don't really get it. Well, no, I do get it because I think it is, the hand is falling down by gravity, as is the ball and chain. Then I'm applying a force to move the hand up. And I think that effect applying to the ball and chain is somehow delayed or something. I don't know. There's just something weird going on there. Well, one thing that I could try just for fun is I can actually put the priority the other way around and see if that makes any difference. So that means that the hand stuff is done to the hand first. Let's see if that makes any difference for this. No, still same problem. It just pulls the chain apart. Boink. And I didn't get it. It just doesn't make any sense. When you look at how the ball and chain works properly, and especially when I go look at this hanging ball and chain is behaving exactly as I expect. The joint on the static body is causing it to nicely stay in place. And then everything is nicely doing what it's supposed to do. But the moment that I pick up, even though I'm just positioning my hands with forces, could that be a part of the fact that I've got inertia turned on this thing? Let's see. I've been having some luck with just leaving the headset on and using virtual desktop. Yeah, I've done the same sort of thing where, for instance, in Meta Developer HUD, I just disable the proximity sensor. That means that the headset doesn't go to sleep. And then actually using the, in Steam Link, I'm just using the display on screen to see what's going on. Anyway, that didn't do much. So one thing that I want to try, I know this is going to cause me a whole bunch of headaches as far as rotation is concerned. Let's go put this back to normal inertia. It's probably going to screw up the rotation of my hands. Yep, it is. But at this point, I don't really care because I just want to see if that solves this issue. No, it doesn't. So it has nothing to do with inertia. My chain still gets stretched out. It makes no freaking sense. What am I doing that is causing this to go wrong? This is a rigid body. I want to see what happens if I make my hands really light. Just to see if that has any sort of impact on what we're doing. Now, obviously with a, this is probably going to make the, oops, sorry. Probably need to have much lower, yeah, because it's, ooh. Why is the right hand working fine, but the left hand, oh no, it's not. Because I made it, whoa! Okay, my hands are flying around like crazy. So because I made my my hands a tenth of what they were, obviously, let's leave that there. Obviously, that means that this needs to all go down by a tenth. I'm just gonna purely do that. So remember to make them go higher again. No, that's still. No. Can I? No, too late. All right, that's funny as. Okay, so a failed experiment there. Go back to that. Back to that. Back to that. Back to that. Ugh. This is so frustrating because it feels like we're so close to have something that works properly. Oh, what? Okay. Hold on, guys. I have someone at my door. I will be right back. Delivery. Yeah. I'll be back in a second, guys. Oh, just need to Sorry about that. That was some delivery, and I needed to put a few things in the fridge before they go bad. Okay. What did I screw up and not properly save back? Maybe I just didn't save. That's also possible. Hey, cat. What is it, cat? That's back to that. Still got all those. Yeah, that's what we want. That needs to be top level because it needs to be moving independent. What is it, cat? Stop. Stop it. Okay. All right, let me try one time and see if it just wasn't saved. And that's why it was going nuts. Ba-ba-ba-bum. Come on. There we go. Okay, yeah, it's back. So I obviously didn't save something properly. But we still have our problem. Yeah, it's a moment that. It's not super bad, but it is fairly obvious that it stretches it out. It's actually, it's not as bad as it was before. What did I change? Anyway, let's swing this now. Whee! Okay, come on. Let's see if you can. Yeah, you can fix yourself. Okay, sorry guys. I got flown up all the way to the other end, and the whole ball and chain is completely pulled out. So, okay. I am in the wrong spot. So I am not quite sure why, because the ball still hits. This is just me hitting my player body. So the only thing that I can think of is that when it hits the raycast, you can't really. Cat, what were you doing? I think the cat wants to have dinner or lunch. Actually, I need to get some lunch in a minute. Yeah, I'm not quite sure why, because I've made it so that whatever I've picked up, I can push into my player body, but the rest should. Oh yeah, no, that's. I am. Oh, here, it happened again. Yeah, so whatever I've picked up. So the pill, the top one that I've picked up, that gets part of my collision exceptions that won't collide with my body. But everything that is attached, because these are all separate rigid bodies, they are colliding with my player body. And the nice thing, obviously, is that is going to go and prevent that from entering my player body. But there's a certain situation where it does, and then my player body's logic sort of panics and suddenly makes me fly away. And I'm not quite sure why. I can kind of get the jumping that we had at the beginning of the stream, because if something goes under, it's the same effect as when I go over here, right? That if I go up to something, I get jumped up. So obviously, if I push something underneath me, it's like I'm going to try and step up on that. It really jumping high is a bit weird at that point. But I'm guessing that at that point in time, obviously, if it is whatever I'm holding in my hand, I jump up, my hand pushes up, whatever is attached to my hand is there for interacting with the player body, and things sort of spiral out of control at that point. That's my guess. That's my theory. So yeah. Oh, boink. So I don't know. Yeah, I do get the feeling that it is more stable than it was. Now, obviously, something like this is something that we still need to do something with it. So the idea here is if we're really pushing away from that joint, and maybe I should. This is what I don't get, because I'm moving that. Why is everything else also moving like that? So obviously, if I grab this and my hand stays on that pin joint, we are good. But the moment that I move it too far, the moment that I can no longer hold the object, I think that's actually going to have to be a function of my pickup. That if the object that I've picked up can't move there, yeah, that's going to be the interesting way. How can we detect that between where we think we need to be and where we are? And as long as I have you can see that I'm still. I really wish that this would not pull apart. I really want my hand to stay on there. Yes, I'm putting a force on my hand, but it shouldn't be pulling it apart like this. I don't know how well you guys can see it, but my hand is pulling away from the pill. I really should have the. I'm actually going to go and visualize that static body thing, so that you guys can see where it's actually supposed to be. World. Citizens. Tiny little thing. Okay, seeing that I've now nicely got the ball and chain here, actually want to make sure that that is nicely underneath. No, that is. Actually, I don't mind that like that, but it means that my pin joint, I actually in this case want the pin joint to be in the middle. And this one I have already got exclude, so that's cool. So now we have that our ball and chain is nicely rotating around that ball. The other thing is I'm actually tempted to not have space here. So I want to actually change that as well, because that makes it easier to recognize that we actually don't have I want to make this first because it's between that and that. So this should actually be 5, and then this should be that. So that is now exactly on top of that. Perfect. Now, hopefully that doesn't mean that it's automatically colliding exactly at that point. And again, that's where the collision margins should come into play. What is set as a margin here? Yeah, that should be good enough. I think that will work. I'm guessing, is that nicely? Oops. I think so. Yep. Oops. Yep. There's a pattern here, so that makes it a lot easier. Okay. Yep. And here. No. Yeah, I think that is what it is. Nicely hitting. So let's hope that that doesn't collide and screw it up even more. But if that works, oops. Cool. We should really visually see when things go wrong. And the moment that I grab it, you can see that immediately it pulls it off. And immediately that all goes wrong, okay? And it can't really correct from that once it's gone wrong. That's really interesting. Although if I maybe move it a little bit like this. So when I just touch it, this is going perfect. So the fact that I'm now exerting a force and I'm not joining, that is working exactly as I'm expecting it to work. Which is still very cool, right? You know, I can just do friction things. That works. But the moment that I join my hand to it, okay, the moment that I join my hand to it, it just goes wrong. So there's something in. Oops. Again. Yeah, it's because the bloody thing. I need to figure something out about that. It is hilarious, but it is not good. All right, so I suddenly realized that I'm adding a where are we? So in my pickup, I'm adding a 6-dot joint. And I'm not actually setting it up in any sort of way. Now, something that I actually might want to do here is, do I want to make it possible to configure that joint? All right, just for fun, let's see, how am I'm just removing a joint here, adding it there. What? So that all goes from joint 3D. So I definitely want to. I want this to be untyped, so that I can easily switch what sort of joint I'm doing. And I know that this is wrong, but I just want to see if there's a behavior change if I do a pin joint change. So obviously with the pin joint, I suddenly can, you know, things can move in a way that I don't want them to move. But I just want to see if the constraints on the pin joint work differently. So maybe it's just because we're using, let's first start here and see. No, it has the same problem. Come on, go back, go back. Eventually, it corrects itself. Let's have a see. So the pin joint, the problem that that does is it allows me to do that, which obviously is not what we want. And same problem again. I really need to figure out, why am I being pushed back? Because I didn't think that it could actually do that. I don't know. I just don't know. The feeling that I'm getting is because I'm probably exerting really big forces. I'm just overpowering things. But without the big forces, my hand is not moving properly. So, is it that because I'm using these really big values, is that really necessary to get the behavior that I want? Or is it because we've been doing trial and error and we just got everything a magnitude higher than it really needs to be? Which we can obviously test, right? If we go, well, let's do that inside of code to make sure that we keep the let's half everything so that everything's still in the same balance. But I'm expecting us now to get a hand that won't follow. No, it's still happy. Okay. Does that now still overpowers that? I do get the feeling that I've got more distance on that, but okay. Let's see if I now go to a 10th. Because again, it might just be the ratio that is important. Okay, now we can see that we actually have some lag. But I want to see what happens now if I do this. Now it still pulls it apart. I do get now that my hand stays closer to there, but it's still being pulled apart. And the thing is, what I'm expecting is that because that is joined together, that even if I put a high force on this, it shouldn't be pulling it apart. That is the thing that I don't get. And again, I don't know enough about how the pin joint logic works behind the scene. Anyway, it was nice to see that half worked, so I am going to go and put this down to half what it was. That's a good place to start. Although I still want to see if there's a way to make sure that, you know, when I move my body, that I don't get this lag. Because this lag on the body movement, I really don't like. But yeah, that is definitely wrong. That doesn't make sense to me. Yeah, I'm lagging. Yay. But I was before, so. And again, normally when you would do a move and collides to do that, but I can't do move and collide, which is what I did in Extra Tools 1. Because with move and collide, the physics is even worse because it doesn't apply anything and it really pulls stuff apart. I don't know. I'm going to have to give this some more thought. Anyway, all in all, we have the pit controller in there now. And while it doesn't solve my pulling stuff apart issue, at least it does something. No, not that one. This also not. Oh, I got that on here, didn't I? No. Statics are. Yeah, I already have the physics Okay, I want to do something crazy. All right. I'm not sure if this is going to negatively influence our performance, but okay, that makes that go slightly better. But how does it do it? Well, it makes no difference whatsoever. Okay. I was hoping by doing physics in smaller steps. Oh, it didn't save that. It didn't save it. Okay. So now, let's actually double check. Yeah, physics is set to 900. Okay. I just want to see if doing physics in smaller steps, if that is going to slightly more bouncy. What is that? Well, that is definitely doing now what I'm expecting it to do. See, this is what I want. That my hand stays nicely on that, and my hand now pulls away from it. So this is doing exactly what I wanted to do. Now, I hated that that bloody thing fell on the ground again. How's this doing with something like this then? Yeah, so that works fine. All right, I'm going to restart it. Okay, so my whole problem gets solved by putting the physics rate up to something completely nonsense. Okay, what about if I grab this guy? Okay. Yeah, I get that. You know, the super heavy, so. Whee, whee, whee. Okay. Uh-oh. Come on. I want you back on there. Yep. Wait. All right. All right. Okay. We're on to something here. I'm not happy about this as a solution, but it kind of does make sense. It also makes sense now, certain other things that I've been told by people who have been doing this sort of stuff in Unity, who have also been running things on physics engines on much higher frame rates. Okay, is that now? Okay. All right, so now the question is, how high does the frame rate need to be for this to actually make sense? So let's go to 5. So this is a multiplier by the frame rate. So I'm running at 90 frames per second. We're now doing it times 5, which means that our physics, well, basically our physics runs 5 times as fast as our okay, that is still good enough. It's still doing what we want with this one. Is it still doing what we want with this one? Oops. Oink. Oink. No, that is now pulling apart again. It's not really a solve, but it is kind of a solve. The problem with this is, so okay, so we can get it to work properly by giving it an insane physics rate. But obviously having an insane physics rate means that we are losing a lot of performance on our physics. Which is fine on my really fast computer, but it's probably not going to be very happy when running on a headset. I'm really starting to wonder whether I'm asking too much of this. I am really starting to wonder. Oh, what? Oh, I'm looking at the wrong physics engine. It's like, why is it on a jolt? But it's, yeah. Okay, number of solver iterations for all contexts and constraints. The greater the number of iterations, the more accurate the collisions will be. However, the greater impact. Okay. So bias for all physics contacts define how much bodies react to enforce contact separation. You know, one thing that I always really worried about, the maximum distance a shape can be from another before they are considered separated and the contact is discarded. These settings make absolutely no sense in VR. All right, hold on. Let's put this back to 1. Oh, we got real crappy stuff now, but okay, let's first make sure that we get our. Well, if you have a PitHands example in GitHub, I'd love to take a look at it. So, don't know if you can copy the link. Yeah. Okay. Really? Just because I set the physics interaction normal now, you're gonna screw me over like that? Let's double all this and see if that makes a difference. No, it's not happy with that. So just because I'm now back at normal 90 degree. Oh, even my ball and chain doesn't work properly at this. Why are you doing this to me, game? Okay, I'm gonna go the other way, other direction. 5, 5, 50. So that should create a lot more lag. But hopefully that doesn't overpower it. Still, this is infuriating. Okay, let's go back to my original. Because this is also one where I'm sort of going like, okay, is this going to screw me over? Okay. Why? So this means that what does it mean? That's a really good question. That means that my well, let's just do it back in rate of 2. So really, it hasn't. Still think that I might just be doing that wrong. I think that might just not be the way that it should work. However, I just want to have a look at all this. So I'm happy about all that. Gravity is fine. Contact site recycle radius. Maximum distance a pair of bodies has to move before their collision status has to be recalculated. So yeah, that's fine. So that's 1 centimeter of movement. Max centimeters. Max separation of 5 centimeters. Okay, maybe. We're allowing penetration of 1 centimeter. That is maybe a little bit much. And this is what I'm wondering if this is maybe our problem, because we got this. Well, it's a bias. So anyway, I don't know. The thing is, I think that if we put this on 32 and this on 1, in theory, that should give us the same. Let's see if it still screws up that way. It's a little better, but not much. That still that still screws up completely. And again, it just doesn't make sense. Why does the whole chain break? Even though when it's on a static body, it works just fine. Whoa! Hi! Okay. Yeah, I really need to figure out why that's happening and how I can stop that from happening. Can you move all the way back? Does it make sense? No, I'll just quit. It's going too slow. I'm gonna have some lunch, everybody. I'm gonna give it some more thought. Yeah, Jonathan, if you wouldn't mind putting a link to your example in like the Discord, that would be really cool. I'd love to have a look at it and see if I can gain any clues why my thing is not working and yours might. Unless I'm just asking too much of what I'm trying to do here. I don't know. That said, we do have the PID controller in essence working. By the way, I'm going for lunch in a few minutes, so I'm going to stop the stream in like 2 or 3 minutes. I might be back online later today. I have to see how things go and how I feel after lunch, or whether I just want to, play around with this a little bit myself. Try making the links way bigger. Yeah, maybe. Still, it would have still got the same problem, I think. So yeah, no. The thing is, I might be back later, but I'm sort of, this is getting to the point where I'm just playing around with values and trying to figure out what works. I don't like the idea of using the physics rate multiplier. It's a really cheap way of getting things to work, and even for this, I kind of want as much to work with default settings as possible. Now, if that is not possible, and we just come to the conclusion that for this sort of physics to work, we just need to run the physics at higher rates, then that, so be it. But that's going to have a whole bunch of new problems and a whole bunch of performance considerations. Now, there's a whole bunch of things that could be here that I'm doing wrong. One is that I might be applying delta too much here. Again, the thing that I'm really worried about is that I'm overpowering forces. The other thing, obviously, is that in overpowering forces is that I probably need some sort of force fall off. Especially when I'm grabbing an object. But again, I'm worried about at that point in time that in a situation where I'm just grabbing a heavy object, that suddenly it'll just drop to the ground. And that's not what I want either. You know, there's just something that is not working the way that it should here. And I might just be overlooking something very simple. It's very possible. So yeah, I'm going to be doing a lot more experimenting, and I'll look at some examples of what other people have built and see if I can glean some ideas of what I'm doing different, or maybe there's some people who might tell me like, yeah, I ran into the same problem as you have. This is what I did about it. All in all, though, I am quite happy about the progress. I do think that we have far more control with the pit controller than what I was doing before. So yeah, there's more experimentation to be had. But I do think that with this setup, I can get to something that works in a way that I'm happy with. And else, if I really get to a point where I get to the conclusion like, nope, doesn't work, I might eventually have a mode on the collision hands that we do apply move and collide to move the hands, and that we just do a rotation. Although that gets us back to the problems that I had with Extra Tools 1. And yeah, let's see. And the other thing I still need to figure out is, why does player body sometimes get launched? And again, I think that is because we are dropping an object, it gets inside of a collision space or a collision shape, and the physics does panic at that point a little bit. So, although I didn't think that collisions would act upon the player body in that way, but I don't know. I definitely think that I need to put a velocity maximum on the player body, that if the player body moves more than a certain amount, we just cap it off. Like, no, not allowed to do that. You're not going to do that sort of movement. Or maybe cap it on based on the that it's not allowed to speed up. That would actually be a really interesting one. That when I look at my player a locomotion handler, where we're doing our move and slide, is we could see if the velocity after the move and slide is suddenly bigger than the velocity before, that we would constrain it. And we say like, no, not allowed to increase the velocity. I think that's actually a pretty neat idea to do here. Assuming that that is, because it could also be the push rigid bodies that is causing this problem. Although the push rigid bodies should be pushing things away, not us getting pushed. I don't know. Food for thought. Anyway, that's where we're going to keep it for now. Yeah, lots of progress. Not yet where I want to be, but I feel like we're getting all the pieces of the puzzle together. And once we make them fit properly, we'll see what happens then and where we go. All right, everybody. Thank you all for watching. And can't promise that I'll be back today. I'm not quite sure. I'm kind of hesitant doing a stream where I'm just trying things. Makes for a boring stream. But I'll probably be back sometime during the week, continuing on this work, and hopefully I'll have some things to share. So again, thank you all for watching, and till next time.